So we discussed a Carnot cycle in the previous video. A Carnot cycle is an ideal cycle where all processes are reversible in the cycle. A reversible process is one where you can change or reverse the direction of a process without any change in the magnitude. For example, if you have a heat transfer from temperature at T1 to a temperature at T2, you can reverse that from a temperature at T2 to a temperature at T1 without any change in the magnitude. So the direction of flow will change, but the magnitude will remain the same. And this is applicable for work transfers as well. If you have a turbine work coming out from the turbine or coming out from the system, you will reverse it in such a way that the work is given into the system of the same magnitude. The magnitude of the work will be exactly the same. So it's just a change in direction. So what happens if you change all the processes or the direction of all processes in a Carnot cycle? I have shown here is a reversed Carnot cycle. If you remember, we had heat transfer from T1 to the heat exchanger, which is now reversed from heat exchanger to the source at temperature T1. And in the Carnot cycle, we had work transfer coming out from the turbine out to the system, and here it is given into the turbine, so that is going into the system. And we had a heat transfer of Q2 from heat exchanger to sink at temperature T2. Now that has been reversed, that is the heat transfer is from the sink to the heat exchanger. And we also had a pump work that is given into the pump in Carnot cycle, which is now reversed and shown as a work that is produced from the pump and coming out to from the system boundary. So what is the significance of a reversed heat engine cycle? Now if you think as a source at say 300 degree C, this is where this is a heat engine cycle I'm talking about, and a sink at say 20 degree. This is what usually happen in a heat engine, and a turbine work will be produced and a pump work will be consumed. So this is what happens usually in a heat engine, assuming the heat flow is in the opposite direction. So if it is a heat engine, the heat engine will transfer heat from a high temperature source to a low temperature source and produce net work. That is heat engine. A heat engine will consume or take heat from a high temperature source and release heat to a low temperature source and produce net work. Whereas if you reverse as shown in this diagram, it will consume or it will take heat from a low temperature source and reject heat to a high temperature source and consume network. So it will not produce network, it will consume network, but the heat transfer will be from a low temperature sink to a high temperature source. So the name will change slightly. These engines or these processes combined is called a heat pump or a refrigerator. So a heat pump or a refrigerator will remove heat from a low temperature source and reject heat to a high temperature sink and consume network. Whereas a heat engine will produce network and take heat from a high temperature source and reject heat to a low temperature sink. A heat pump is also called a refrigeration. So if you imagine the engine of your car, the temperature inside the engine will be 600 700 degree after the compression, whereas the rejection or the exhaust of your engine will be to the ambient, which is at say 30 degree C. So your car engine produces network taking heat from a high temperature source, say 600 700 degree C, and reject it to a sink of ambient temperature, but it produces network. Now if you consider the refrigerator in your house, or the fridge freezer in your house, that will consume power from in the form of electricity, but it will remove heat from within your refrigerator to the ambient, which probably at a high temperature, and consume a network. So these cycles both are, in theory, they are just reversed. The operations involved are pretty much similar. One will be a pump and the other will be a compressor. One will be a heat exchanger, the other will be a condenser, and things like that. But in principle, all the processes involved are very similar. It's two heat transfers and two work transfers. A heat engine produces network and a heat pump consume network. A heat engine removes heat from a high temperature source to a low temperature source, whereas a heat pump removes heat from a low temperature source to a high temperature sink. We will see more of the different types of refrigeration and heat engine cycles in the next videos. Once again, thank you for watching. Please leave your comments in the comment box if you want me to discuss a specific topics, any specific topics. Thanks again. Thanks very much.